13 hearts in a deck out of the 52. Or means I add kings. There are 4 kings in a deck. But there is overlap because there is a king of hearts, which means I counted it in the heart section and the king section. I counted it twice, which means I have to minus 1. So I get 13, 14, 15, 16, 17, minus that 1 extra, 16 out of 52 cards. 16 out of 52 cards is 31.31 with 31% chance of pulling a heart or a king. Now the percentage went up because there are a lot of hearts compared to on this last one, there were only 4 and 4, so you're more likely to pull a heart or a king. Determine if the following question is mutually exclusive. So remember, we're trying to check. Mutually exclusive means that they cannot occur at the same time. Not mutually exclusive means there's overlap. So I'm checking. Is there no overlap? A single card is chosen from a deck of 52 cards. What is the probability of choosing a king? There are 4 kings. 4 means I add clubs. There are 13 clubs. Now you have to ask yourself, can you have a king of clubs? And you can. There is a king of clubs, which means there's overlap. Not mutually exclusive. So I have to be really, really careful because when there's overlap, I have to get rid of that 1 card I counted twice. So minus that 1 card. 4, 5, 6, 17, minus that 1, 16 out of 52. And we already did that, it was 0.31. 31%. Now I have 2 events are independent. So when you think about being independent, it means you can do things on your own. If the occurrence of one does not change the probability of the other occurring. What is the probability of rolling a 2 on a die, 1 out of 6, and means I'm not adding anymore, and means I'm multiplying, flipping a head on a coin? Well, your probability of getting heads on a coin is 1/2. I multiply them across, 1 times 1 is 1, 6 times 2 is 12. The decimal would be 0.08 or 8%. So that is independent. A jar contains 3 red marbles, 2 blue, and 6 yellow. I'm going to add those up so I have my total. 3, 4, 5, 11. A marble is chosen at random. After replacing it, which means I take a marble out, and then I put it back in, a second marble is chosen. What is the probability of choosing a green? Oh, there's no green, there's only red, blue, and yellow. Edit. We're going to make it a blue. Okay. Choosing a blue marble, so 2 out of the 11, and add or multiply, and means multiply, then a yellow marble. There's 6 out of the 11. Equals 2 times 6 is 12 out of 1. Which equals 12 divided by 121. 0.099, so it's going to round to 0.10, which equals 10% chance of pulling out a blue marble and then a yellow marble. They are independent because I'm taking a marble out and then I'm placing it back in. Example 5. If the occurrence of one event does affect the probability of the other occurring, then the events are dependent. They depend on each other. The probability of an event occurring, given another one has already occurred, is conditional. Okay, these ones, we have to be careful. A card is chosen at random from a standard deck of playing cards. 52 cards. Without replacing it. That means I take a card out and I keep it. Then a second card is chosen. What is the probability that the first card is a queen? Okay, let's think. I have my full deck of cards. I reach in right now at this moment. There are 4 queens out of the 52 cards. I take out a queen. There are now only 51 cards left. And multiply. The second card is a jack. So I'm reaching back in. One of the cards is already gone. How many jacks are in there? 4 jacks out of the 51 cards. And I pull it out. So my probability would be 4 times 4, 16 out of 52 times 52, 2704. 16 divided by 2704 is 0.006, which is equal to 0.6%. That's insane. Very unlikely. Now, what is the probability that the first card is a queen? So I'm reaching into my deck of cards. There are 4 queens right now out of the 52. And means I multiply. I take that queen out, so it's all gone. There are now only 51 cards because I'm not putting it back in. The second card is a queen. I already took a queen out. Now there's only 3 left, which equals 12 out of, did I do 52 times 51? Oh, I made an error. No. Okay. Dang it. Here we go. 4 times 4 is 16, which is fine. 52 times 51. For those of you who caught me, good job. 2652. 0.006. Aha, thank goodness. Okay, we're okay. Those percentages are fine. All right. 4 times 3 is 12. 52 times 51 is 2652. I'm going to write it as a decimal. that 5 is going to round the 4 up, which would be 0.5%. So we went over dependent. That is when you're taking something out and you do not put it back in. It affects the next fraction. Just like on this one, when I took out that queen, there were only 3 queens left out of the 51 cards. Up here, they are independent because my denominators, when I take out that king, I am placing it back into the deck. Oh, independent, here we go. Then rolling a die, flipping a coin, they are independent because they do not rely on each other. Last review. Or means you add, and means you multiply. So whenever you read through a word problem, notice I circle what it says so that I remember add, multiply, 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 multiply. Okay, good luck today. Email me if you have questions.